Hi, my name is Ken Lasseson. This is a update on a feature that was there, which is being slightly expanded and improved, and probably most people overlooked it. Especially if you're into microbiology, it becomes real interesting feature. The first thing to understand is the nightmare before Christmas, taxonomy nightmare. And basically comes down to every lab does something different, uses different reference libraries. So what we end up having is, well, to put it into a Western sense, we have one lab using the King James Version, another one using the Jerusalem Bible translation, a third one using Greek, and the fourth one using Hebrew, or Danish translation, or Italian translation of the Bible. They are all going to be similar, but they're all going to have different nuances. Somebody will use one word here, a different word there, and the common interpretation of those words will be sometimes very significantly different, which is one of the joys. I take part in a bilingual Bible study, and the common meaning of many sentences in the other language and in English will often be different. And then go over to the Greek and refer to something like the kiddos exhaustive concordance of Greek phrases, and you get a third meaning. You get three different meanings of the same, what should be the same. So it's the same thing with the microbiome. We have different interpretations of the same raw data. So the result is what you develop from it is slightly different. In other words, the theology in some ways depends on the interpretation on the language itself, which is a lovely philosophical, theological point. But let's get over to the actual more interesting stuff. So if you do a look at bacteria, you will, of course, you can search however you want. And for the first example I'm going to do is I'm just going to do bifidum, bacterium bifidum. Click here. And what I did do was I moved this up to the higher in the list so people see it. Most people just weren't noticing it. And it is talking about interaction. Bacteria A may encourage or discourage bacteria B. We have enough data now to be able to discover what the differences are and what actually influences another one. How does it influence? Bacteria A could produce a favorite food for bacteria B. Hence, if A goes up, B goes up. Alternatively, bacteria A could be competitive with bacteria B and produce toxins to try to diminish bacteria B from consuming the same food. So it's back and forth. And what we have here is things which are statistically significant are listed here. And what we have is things. Now, notice we have here, this is all data. And that means mixing data from biome site, from ubiome, from Thrive, putting them all together in one big melting pot. And we end up with 5 items. But I've skipped ubiome now because it's not an active testing one. But if we go over to Ombre Labs, let's see what we have. We end up with 6. We have more things because we have less noise in the data. When we go all, we get noise in the data because of different interpretations. So we have things there, and we can also click here for impact and can see what the degree of impact is. These two things will cause the bifidobacterium to decrease. As those goes up, that goes down. These things causes it to increase, which is a different set of things. So if that goes up, the bifidobacterium goes up. Now let's go over to Ombre Lab to biome site. And there we have 11. So take everything together, we had only 5. Going to Ombre Labs, we have 6. Going to biome site, we have 11 associations which are significant. The more precise we get the definition, the more relationships we have. And again, we can just click here for impact, things that decreases it from other bacteria, things that increases it. Now let's go back and do one more. And this is just what I'm going to do, mainly because I've been getting lots of messages about it. And there we go. Let's go over and see what we have here. Again, oops, it's missing. We don't have a link. And if we don't have a link, it means we cannot find any association which is statistically significant. Whoops for me on that. Let's go over and let's just look at, let's try a different one. Let's try Akkermansia. And let's try Municipal. And there, we have 7 interactions. And what we have is this hierarchical Akkermansia is part of this one, and which is now part of that one, which means it's sort of saying if people in a county have increased population, then people in the state has increased population. These are the same hierarchy. Does that happen for everything? Yep, it looks like it's happening everywhere. The same thing, bottom side. We have one site difference. We have a different genus actually has a positive impact, but it only shows up according to how biome site is interpreting the data. Okay, now you need to go back and remember the fact that we get different data, which different things. So you get different associations based on how the interpretation is done. Okay, so that is the long and the short of it. And go off and explore. Remember, you may find different bacteria listed there, different total families or things, and they have a interaction. Some cases, like for Privilata colpri, you'll find no associations because there don't seem to be interactions with the other things. And then for other ones, you'll find a hierarchical, as in, oh, guess what? We have association with people in the same hierarchical stack. So we have 3 main types of associations being exposed, and you just have to go in there and take a look at what interests you and what impacts it. One of the reasons I added this feature originally, and still do, is if we deal with bacteria where we have no literature on what influences it, we then flip over to see, okay, what bacteria influences? This bacteria increases or decreases, and guess what? We can take that information and add it to the artificial intelligence program to get suggestions, because what we're basically doing is, okay, I don't know who your friends are, but I know who your friends are, so I'm going to make your friends happy, and hopefully the side effect will cause you to be happy too. Same type of logic. So it is encouraging the bacteria whose presence will encourage the bacteria you're trying to change. So it is a second generation inference for suggestions. Okay, and I think at that point in time, I'll shut up and let you get back to enjoying the site.